Descartes. Renaud Descartes. It's named after him. Cartesian coordinate system is named after him. Okay? The story goes, how he designed it, the story goes is he was a sickly child. You guys all heard of Renaud Descartes? Have you ever heard of the name before? He was in a lot of different areas of philosophy. His famous quote is, "I think, therefore I am." I think, therefore I am. He actually is the one that originated that quote. You may have heard the quote before, but maybe not him. I think, therefore I am. What does that mean, by the way? I think, therefore I am. You've heard it before, right? Some of you are shaking your head. Yeah, I've heard that before. Did some rap singer come up with it? Yeah, baby! What does it mean? I think, therefore I am. Say what?
I think so.
It's good. It's actually had a bad shot. I mean, you're kind of close. Anybody hear that? Say it again.
I think, therefore I exist.
I mean, there's more to it than that. But that's on the surface, that's right. Yes?
Like whatever you put your mind to,
That's what most people think, and it's not. That's not the origin of what it was meant for. It was more philosophical than anything. Okay? I shall. I think, therefore, I am. Thank you very much for the opportunity. I think, therefore, I am really makes us different. We exist differently than all the creatures on this planet. In other words, my dog doesn't think about his existence. We do. My dog doesn't think about the future or the past. We do. My dog doesn't think that he's a nice guy, she's a nice gal. We do. Okay? All he cares about is what's for dinner, what's to eat. Any new puppies in town? He's a male. What smells good? I smell something. Ah, that's what I smell. That's all they care about is their senses. Okay? And so I think, therefore, I am is more of the existence factor. It's, yeah, we exist, but we exist better than the animals on this planet. Most animals are not thinking about the past and the future. They're not thinking like we are. So it's a thinking kind of thing. We exist because we can think about it. We can think on our existence and how to make our existence last. Or not last. Okay? So consequently, that's where I think, therefore, I am. This Renaud Descartes is the one that came up with it, and he kind of came up with it on the fly. And I mean that in two ways. As a young child, he came up with this Cartesian coordinate system, sleeping in bed. Kind of like my roommate. I had a roommate who loved to sleep. He loved to sleep so much, he put a mirror on the ceiling. He told us he wanted to watch himself sleep. He said, "Oh yeah, oh yeah, that's what you mean, all right." Yeah, there's my roommate story. But anyway, this guy, this Renaud Descartes, he actually was looking up at the ceiling one day, and he saw a fly buzzing around. And he could swear every time it landed, it was landing in the same spot. Okay? So he kept saying to himself, there's got to be like a piece of honey or something there that's attracting that fly. And there wasn't. So he decided one day to make lines, draw vertical, horizontal lines, and then put like a little pinpoint every spot that that fly landed. Hence, the graph or the grid system. And so what he did was he noticed that every spot that that fly landed was not, it was totally random. And the only way you could do it was by spotting the lines that it was closest to. And so you can pinpoint things. And he sold that idea to the military. And now everything in the military has a scope on it for targeting systems. Anything with a screen that you don't see on your watch or on your phone has a grid system on it. Everything we use today was all because of that guy spotting a little fly and decided to throw some lines and made a grid system. And ever since then, we call it the Cartesian coordinate system. Now, the book has another name for it. They call it the rectangular coordinate system. But it was Descartes who came up with the idea. Embed, of all things. Anyway, so what we have is a bunch of lines. But I'm not going to draw the lines. I'm going to draw numbers instead. Here are my negatives. Here are my positives. Oops. And these are my negative values for x, or my horizontal line, and then I have my vertical line, which has positive values above it, and minus values down below. And that in some places you'll see, well, basically this is how the graphing paper was designed for. And so you got a grid system you can form from these lines. Okay? All right, so hence we have, this is essentially the Cartesian coordinate system. Okay? We have an x-axis, y-axis. This is called the origin. This is our starting point, origin. Origin. Looks like a onion. All right, so there's the origin. Now, in order to plot points, we always just pretend for a moment that this has two dimensions. We have something called the horizontal dimension, and we have something called the vertical dimension. And so we're going to plot points at certain places. In order to say, for example, this point here is at the x, which is 1, and the y, which is 1. So what we're calling this is the x-axis, and these are the y's. So if I have this point, I could describe it by 1, 1 by this symbolism. I'm going to use parentheses, I'm going to use comma. This would be my x, this would be my y. Okay? I think a lot of you know how to do this. I'm just trying to go through the steps a little bit, just trying to take it slow. So now, when we graph points, when we plot points on a line, we also call this the independent variables. The x are considered the independent variables, and the y's are considered the dependent variables. There are certain names we call these, dependent. We also call them the inputs. These are another word we use, inputs, over the outputs. And I'll explain that in a second. But these are certain names we give our x and y axes. So as far as the graph goes, we call them x-axis and y-axis. But with certain applications, we call them input outputs, or independent variable versus dependent variable. Okay? So these are certain names. We're going to refer to them. We're also going to use a chart of values. This is called a chart of values. And if I have 1, 1, 2, 1, so I'm going to call this 2, 2, 3, 3, 4, 5, 6, 8. I'm going too big. Let's stay at 3. So 1, 1, 2, 2, 3, 3. So we'll keep it simple. So now, if I take these values on the chart, this is my x value, these are my y values. These are my inputs, these are my outputs. I get this point. So on the chart, 1, 1 looks like that. This is the way it looks like on the graph. 2, 2 will be x is 2, y is 2, would be right there. So that will be represented by 2, 2. And then 3, 3, x is 3, y is 3. In the way that will be represented there. So basically we have, if we connect these dots, we have a straight line, and it's called a linear graph. This is called a linear graph. Oh, the yawns are coming. This is called a linear graph because it forms a straight line. So now, let's graph some, these are some easy ones, let's graph some tougher ones. So I want to graph some ordered pairs. So let's do another chart. So I got 0, 2, minus 1, 3, 2, 5, minus 2, 7, and 3, 6. I draw a new graph. Let's move stuff out of the way. So let's put black out. Okay, let's go to 3, 1, 2, 3, 1, 2, minus 3, and 7, 7. Okay. We also have quadrants. This is the first quadrant, Roman numerals. This is the second quadrant, Roman numerals. This is the third quadrant, and this is the fourth quadrant. Okay? These are Roman numerals we use for the quadrants. We don't use Arabic numbers, we use Roman numerals. Now, let's look at this first set of points. This is my x and this is my y. What quadrant is 0? Well, where's my 0, 2 going to be located?
In the first one.
Well, this is not necessarily a quadrant. If I move 0 for my x and y, I'm actually on the y-axis in the positive section. So that's where 0, 2 is located. Anybody see that? So think of this as a sort of a robot arm, and it wants to move to the x first. Basically, you want to look at your x's first, and since x is 0, it stays at the origin. And then as y goes up to 2, this thing shifts up to 2. So the robot arm comes back to the origin. Minus 1, which way am I going to go? So shift left, that's where my x is, minus 1. And then 3 is going to go where? Up or down? Up, shifts up, right there. Okay, so now, where's the robot arm going to go next? 2, 5. Right 2. You gotta be more specific. You just can't say it right, otherwise you go. You gotta be more specific. If you're gonna talk computer talk and you talk to a robot, you gotta be very specific. So I'm at the origin. I go to 2 places to the right, right? Now where do I go? Up. Tick, 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 right there. So, in a sense, you should think the same way for now. If you're not sure on how this is gonna work, look at your x values first, shift to that, and then your y values second. Okay? So minus 2 is going to shift where? First. Negative 2. 1, 2. So left 2, and it's going to go where next? Up 7, so it goes up here. Okay? And then the last one starts at the origin. Where's it going to go? So it's going to go right 3. 1, 2, 3. Up 6, up here. So these 2 points are in the first quadrant. These 2 points are in the second quadrant. Nothing in the third, nothing in the fourth. Now, now let's turn to the algebra side of things. A couple things they want you to do. For homework, you're going to be asked to make your own graph from some data. So let's look at the first example that they use that for, and it says draw a graph. I'm on page 196. Draw a graph for the following data, which show the temperature for the week beginning January 1st. So let's look at this first set of data. You're going to have to do this for homework, so let's get to it. So you got date, and you have January 1, 2, 3, 4, 5, 6, and 7. And then you got temperatures. So you got 35,